to.
Okay, this is priming it. Yeah, keep going.
We have 10 milliliters here that we're going to put. We'll fill it all the way up.
Is that you priming it? Great.
Now we're going to use it.
Wait, what are you gonna put that in? No, you need a 25 milliliter. Will you go get him another one? A 25 milliliter fast. It says, yeah. I'll cut this out, it's fine.
Chat, I have no idea.
I don't know what we're doing either.
Chat, what's your guess if I could drink this?
Stop. Okay, so record to the line of something. No, just pick one as close as you can. You can help it. Nice. Okay, so this is 5. Wait. You can go ahead and pour it in there. So you gotta explain initial and final volume.
So my initial volume in the container was 0. So there's nothing in there. And now the final volume is 5. After putting 5 milliliters of the solution.
And
Flask.
10 minus 5 is 5.
5. Yeah, the whole
Right.
pipette holds 10. I filled up to the 5 line. 10 minus 5 is 5. There's 5 milliliters in there.
Perfect. Okay. So a stock solution is just a concentrated solution that we have to make weaker solutions from it whenever we need. Instead of measuring out chemicals from scratch every time, we just take some of the stock solution and dilute it. When we dilute it, the new solution ends up less concentrated than the original one, and that's because we're adding more solvent, but the actual amount of the the stuff that's dissolved usually doesn't change at all. It's just spread out over a bigger volume now so that the concentration drops. The dilution equation we will use for this is M1V1 equals M2V2. M1 is the concentration of the stock solution before diluting. V1 is the volume of the stock solution that we're going to take. M2 is the concentration we want the final solution to be, and V2 is the final
10
total
minus 7
volume
is 3.
after diluted. This equation works because the moles of the solute stay constant, and we're not adding or removing any solute, just water. So if we know 3 of the 4 values, we can solve for whichever one we're missing, usually V1.
I am using a transfer pipette to transfer the solution from the beaker to the volumetric flask. I draw the solution up to the 7 ml mark, then carefully release it until the manicus reaches the 9
How much are you getting?
mark. It's transfer exactly 2 milliliters of solution. I read the manicus at eye level to ensure an accurate measurement.
Okay.
The meniscus
So that'll be 3.
is that curved surface using when a liquid sit in a glass container, like in a radiated cylinder or a burette. It's curved because the liquid molecule are attracted to the glass wall more than to each other, so the edge get pulled up slightly while the mid stay lower for most aqueous solution anyway. When we're measuring the volume, we're supposed to read from the bottom of the curve, not
Can
the
you
top.
write down that she stopped?
And we need to make sure
she started at
our
7,
eyes
but stopped at 9.
level with the manicus when we read it. If we look at it from above or below, we'll get a slightly wrong number because of the parallax error. It's small things, but actually matter for getting accurate measurements.